Think you know Node.js? Sure, you can write APIs, but can you handle real-world interview scenarios without breaking a sweat? Today, we're covering all the real-time Node.js scenarios interviewers love to throw at you. Stick around, because these questions will test your problem-solving skills, not just syntax knowledge. Crash in production. Your Node.js app was working fine, until it wasn't. Suddenly, the API is down, and customers are flooding your support team with complaints. What do you do? Question. How do you debug a crashing Node.js application in production? Answer is: before we jump into debugging, let's understand why Node.js apps crash in production. Common causes include memory leaks, unhandled exceptions, infinite loops, and resource exhaustion. Knowing these root causes will help us narrow down the problem faster. The first step is to reproduce the issue. Check your logs for error messages or stack traces. Tools like PM2, Winston, or Bunyan can help you capture detailed logs. If you can't reproduce the issue locally, try to simulate the production environment using Docker or a staging server. Next, analyze the logs and error messages. Look for patterns like repeated errors or memory usage spikes. For example, if you see JavaScript heap out of memory, it's likely a memory leak. If you see unhandled promise rejection, it means a promise wasn't properly caught. Now, let's use debugging tools to dig deeper. You can use NodeInspect to debug your app with Chrome DevTools. Alternatively, tools like NDB provide a more developer-friendly debugging experience. These tools allow you to set breakpoints, inspect variables, and step through your code. Monitoring resource usage is crucial. Use tools like New Relic, Datadog, or PM2 to track CPU, memory, and event loop latency. If you notice memory usage growing indefinitely, it's a sign of a memory leak. High CPU usage could indicate an infinite loop or blocking code. Memory leaks are a common cause of crashes. To fix them, avoid global variables, uncleared timers, and unremoved event listeners. Use tools like HeapDump or Clinic to take heap snapshots and analyze memory usage. Once you identify the leak, refactor your code to release unused resources. Uncaught exceptions and unhandled promise rejections can crash your app. Use process.on, uncaught exception, and process.on, unhandled rejection, to catch these errors. However, don't try to recover from critical errors. Instead, log the error, perform a graceful shutdown, and restart the app once you've identified and fixed the issue. Test your changes thoroughly. Write unit tests and integration tests to ensure the problem is resolved. Use a CI/CD pipeline to deploy the fix to production. Monitor the app closely after deployment to confirm the crash is resolved. The slow API response scenario. Your API response is as slow as dial-up internet from the 90s. Your users are frustrated. What went wrong? Question. Your Node.js API is running slow under heavy load. How do you optimize it? Answer is: let's understand why Node.js APIs slow down under heavy load. Common bottlenecks include blocking code, inefficient database queries, lack of caching, and resource exhaustion. Identifying these issues is the first step to fixing them. The first step is to analyze performance metrics. Use monitoring tools like New Relic, Datadog, or PM2 to track CPU usage, memory consumption, and response times. Look for patterns like high CPU usage, memory leaks, or slow database queries. Next, optimize your database queries. Slow queries are a common cause of API slowdowns. Use indexing, avoid select star, and optimize joins. Tools like Explain and SQL databases can help you identify inefficient queries. For NoSQL databases, ensure your queries are using indexes properly. Caching is a game changer for performance. Use Redis or Memcached to cache frequently accessed data. For example, cache the results of expensive database queries or API responses. Just remember to implement cache invalidation to keep your data fresh. Database connections are expensive to create. Use connection pooling to reuse existing connections instead of creating new ones for each request. Libraries like PG for PostgreSQL or MySQL2 for MySQL support connection pooling. Out of the box. Node.js is single-threaded, so blocking code can severely impact performance. Avoid synchronous operations like fs.readFileSync or long-running loops. Use async await and promises to keep your code non-blocking and efficient. If your API is still struggling, it's time to scale horizontally. Use a load balancer like Nginx or HAProxy to distribute traffic across multiple instances of your API. You can deploy these instances using Docker and orchestrate them with Kubernetes. High event loop latency can slow down your API. Use tools like Clinic to measure and optimize latency. Avoid long-running tasks on the event loop by offloading them to worker threads or using setImmediate and process.nextTick to break up tasks. Finally, monitor and iterate. After implementing these optimizations, keep an eye on your API's performance. Use monitoring tools to track improvements and identify new bottlenecks. Continuously optimize and deploy changes using a CI/CD pipeline. Your app just went viral. Congratulations! But wait, your server is choking. Users are getting 502 errors. Question: how would you scale a Node.js application to handle high traffic? Answer is: scale up using vertical scaling. Increase server resources like CPU, RAM. Optimize Node.js configuration, heap size, garbage collection. Use efficient data structures and algorithms. Scale out using horizontal scaling. Deploy multiple Node.js instances using PM2 or Docker. Implement load balancing, Nginx, HAProxy. Use sticky sessions if needed for WebSocket connections. Container orchestration with Kubernetes for automated scaling. Caching strategy. Implement Redis or Memcached for session storage and caching. Use CDN for static assets. Add response caching for frequently accessed data. Implement cache and validation strategies. Database optimization. Database replication, read replicas. Implement connection pooling. Use database indexing effectively. Consider database sharding for very large datasets. Application architecture. Break down into microservices if beneficial. Implement message queues, RabbitMQ, Kafka, for async processing. Use worker threads for CPU-intensive tasks. Stream processing for large datasets. Performance optimization. Enable compression, gzip. Implement rate limiting. Use asynchronous operations consistently. Optimize API response payload size. Your server memory usage just keeps growing and growing until it crashes. Something isn't being cleaned up. Question: how do you detect and fix memory leaks in Node.js? Answer is: detection methods. Use process.memory usage to monitor memory consumption. Implement heap snapshots using Chrome DevTools. Use Node.js profiler, prof flag. Tools like Clinic.js or heapdump. Common causes: global variables not cleaned up. Event listeners not removed. Closures holding references. Large data in arrays or objects not cleared. Improper caching. Solutions: remove event listeners when not needed. Clear intervals in timeouts. Manage caching properly. Use weakmap and weakset for dynamic references. Best practices: regular memory monitoring. Implement proper garbage collection. Use streaming for large data. Implement memory limits. Regular code reviews for memory issues. Scenario: your users are complaining, why does the chat keep disconnecting? Your WebSockets aren't staying alive. Question: how do you maintain stable WebSocket connections in Node.js? Answer is: use a robust WebSocket library. Use a reliable library like WS or Socket.io to handle WebSocket connections efficiently. Implement heartbeat mechanism. A heartbeat, ping and pong, ensures the connection is alive. If the client doesn't respond, close the connection. Handle reconnections gracefully. Clients may disconnect due to network issues. Implement auto-reconnect logic on the client side. Scale WebSocket connections. Use a load balancer, for example Nginx, and Redis for pub and sub to scale WebSocket connections across multiple servers. Handle back pressure. If the server sends data faster than the client can process, it can cause back pressure. Use buffering or throttling to manage this. Secure WebSocket connections. Use TLS and SSL to encrypt WebSocket connections, WSS. Monitor and log connections. Use monitoring tools like PM2, New Relic, or custom logging to track WebSocket connections and detect issues. Handle high latency. Use compression to reduce message size. Optimize message frequency and size. Scenario. Users are suddenly logged out, and they don't know why. Turns out, your JWT tokens expire too soon. Question. How do you handle JWT token expiration properly? Answer is: set expiration time. When creating a JWT, set an expiration time, EXP, to ensure the token is valid only for a limited period. Use refresh tokens. Issue a long-lived refresh token alongside the short-lived access token. Use the refresh token to generate new access tokens without requiring the user to log in again. Validate token expiration. Use middleware to validate the token's expiration on every request. Refresh expired tokens. When the access token expires, use the refresh token to issue a new one. Handle expiration on the client. On the client side, detect token expiration and either prompt the user to log in again or automatically refresh the token. Scenario. Your API is slow, and the culprit? Your database is working overtime like a caffeine-fueled intern. Question. How do you improve database performance in a Node.js application? Answer is: use indexes. Add indexes to frequently queried fields to speed up search operations. Optimize queries. Avoid select asterisk and fetch only necessary columns. Use limit to restrict the number of rows returned. Optimize joins and avoid nested queries. Implement caching. Use caching tools like Redis or Memcached to store frequently accessed data. Use connection pooling. Reuse database connections instead of creating new ones for each query. Normalize or denormalize schema. Normalize to reduce redundancy and improve write performance. Denormalize to reduce joins and improve read performance. Use read replicas. For read-heavy applications, use read replicas to distribute the load. For example, configure a primary database for writes and replicas for reads. Batch queries. Combine multiple queries into a single request to reduce round trips. Monitor and analyze slow queries. Use tools like Explain or monitoring tools to identify and optimize slow queries. Scenario. Your users are trying to upload 1 GB files, and your server just collapses. What went wrong? Question. How do you efficiently handle file uploads in a Node.js app? Answer is: use streams. Process files in chunks using streams to avoid loading the entire file into memory. Use Multer middleware. Multer simplifies handling multi-part form data for file uploads. Validate files. Validate file size, type, and extensions to prevent malicious uploads. Store files in cloud storage. Use cloud storage like AWS S3 or Google Cloud Storage for scalability and reliability. Use worker threads. Offload file processing to worker threads or background jobs to avoid blocking the main thread. Implement rate limiting. Prevent abuse by limiting the number of uploads per user. Scenario. Your API is being brute forced by bots. What's the best way to prevent abuse? Question. How do you implement rate limiting in a Node.js API? Answer is: use Express Rate Limit. Express Rate Limit is a simple middleware for rate limiting. Use Rate Limiter Flexible. Rate limiter flexible is more flexible and supports Redis for distributed systems. Store rate limit data. In memory, simple but not suitable for distributed systems. Redis, ideal for distributed systems and high traffic. Handle rate limit exceeded errors. Return a 429 too many request status code with a meaningful message. And there you have it, real-world Node.js interview scenarios that can make or break your job chances. Which one do you think is the toughest? Let me know in the comments. And if you found this helpful, don't forget to like, share, and subscribe for more tech interview prep.